thank you all for coming. My name's Dr. Joe Collinet. I'm a lecturer here at the University of Chester. Previously, I was at the University of Manchester as a postdoc, and then before that, the University of Liverpool, and that's where I also did my PhD. I've done work on some ways of representing the rules of the road in terms of autonomous cars. I've done work on AI and law, in particular for the European Court of Human Rights, tried to make access to justice a little bit easier. And here I've worked a little bit on how we can find conflicts within rules and how we can resolve them. Okay, so for my first talk, I've got a title about why ethical modeling should be integrated into an AI decision-making process. It's not going to be overly technical, which the title might suggest if you've ever read an academic title. It's going to be fairly high level, and it's more along the lines of, here's some ethical situations. We'll go over perhaps why there might be ethical decisions that need to be made and how we can incorporate that. And there's my slide that basically explains this, but within a bit more accuracy and a bit more detail. So essentially, what is ethical AI? How are we actually going to integrate these ethics into AIs? Some examples from multiple different perspectives. Talk a little bit about law and AI. And then, because we're talking about law, we need to have some idea about liability. And then this brings in fairness and things like that. Then there's a bit on correctness of decisions. How do we actually know that these AIs, regardless of how we model them, are going to actually make correct decisions, and how do we actually verify whether those decisions are correct? And I have a slide that has one positive use of AI, because we don't want it to be all doom and gloom. Okay, so the first thing is, when we talk about agents, AIs, what we really want them to do is to make some sort of rational decision. And so what essentially makes us have rational decisions? So things like the environment that we're within will cause us to make a different decision. The context that surrounds where we are will also do that. But since this is on ethics, it's going to be things like what our personal values are, influences our decisions. But there's also the perceived values of the people in the room as well. So I've put some arrows on. So if you imagine the blue arrow is all our environment, context. The green arrow essentially is our values, and the red arrow is there to say, I've made an action at some point. Okay, so why do we actually want ethical AI? Well, we want, from a computer science perspective, we want agents, AIs, to make the best decision. Now, best is quite tricky to define, but in this case, we're not looking at decisions from a goal perspective or just some best numerical value. We're trying to think from a societal perspective, is this the best decision to make? So it may not be the most rational, perhaps, but it's going to be the best for everybody in the group, something like that. Okay, so ethical AI is a huge area of research in terms from a computer science perspective, and it's got things such as how do you actually deploy an AI ethically? So the AI might not have anything to do about ethics, but I've placed an AI somewhere. Was it ethical to do so? Then there's the other side, which is how do I make an AI ethically? So do I just steal everything off the internet, throw it all in? Is that the most ethical way of training our AIs if we're talking about machine learning? And then there's this other aspect, which is we want AIs to reason about the world around them and to make decisions. Can we model ethics explicitly so that when they're making those decisions, they're going to think about ethics in some ideally mathematical way so we can use them in a computational setting? And ideally, once we've got all this, we can have AIs that will make ethical decisions and explicitly saying, this is why I've chosen to make the particular decision, is because it's the most ethical at this particular time. Okay. So how do we actually do this? we have to go to a philosophy department. And if you're from a computer science perspective, this should send shivers down your spine, because we've got to come to an agreement on what ethics are and how we're going to model them. And I've never managed to get a philosophy academic to sit me down and say, this is what ethics is, and this is the only way it's going to work. That doesn't tend to happen. So we have some sort of compromises on, well, I think this is happening, here's my reasoning why, and then we can work around it. So we want to try and model these ethics so that some sort of computational agent or AI can actually process using these ethics. And the hard part is coming up to an agreement on what ethics are. So whether you're taking a Kantian approach or whether you're taking a utilitarianism approach. Most computer scientists say, yes, utilitarianism, because it gives me a number, and I can work with numbers a lot easier than I can with Kantian ethics. Okay, so trolley problems, always a very popular one. So this is essentially an ethical dilemma. So this is actually from philosophy. It explores the principle of double effect. And if you go to it, it's all, the original paper, it's all talking about double effect in terms of abortion and things like that. That's what it originally was representing. There's lots of different variations on the trolley problem. And so I've got the original one picture there, but I tend to talk about it in terms of autonomous cars choosing between either driver or pedestrian. And so I'm going to have my example where you're driving the trolley. Let's say it's an autonomous car, so you can't control the car. You're in the car, and in front of you, there's a newborn puppy, a baby in a pram, and an elderly gentleman all crossing the road, and the car can't stop. So it could either plow into the puppy and the baby, or it could plow into the wall and kill you. And most people, when I asked it, apart from some of my students, will say, yes, you should plow the car into the room. Well, so plow the car into the wall and kill the driver. Although this highlights the next bit, ethics versus business cases. So we've solved our ethical dilemma by killing the driver, and then usually the next thing I ask it is, would you buy a car that would choose to kill you? And then everyone goes, oh no, I don't think I would. So who's going to buy a driverless car? And also, to be honest, the trolley problem isn't an ideal representation for autonomous cars, mainly because a lot of the assumptions about the car are far too strong. The car can't make probabilities of death by being run over and things like that. So if it does run into the wall, it doesn't actually know whether it's going to kill you or not. There's no real way of calculating those probabilities. But also, it also makes the assumption that these decisions that the car's going to make are instantaneous. Computation takes time, even if it is very fast. And when you are traveling quickly, those small amounts of time goes from 5 meters, 50 meters, depending on how fast you're going. So there is some sort of time. There may be time that even an AV can't react in time. So I've got another example. And this idea is around a robot who is there. It's usually some sort of maintenance robot. And the idea is that the robot can push a human, and there's a human walking towards a hole, but the human's too far away. So there's no scenario in which the robot can push the human to safety at an appropriate time. I have tried to use some generative AI images here. So the first one is my example, which is a robot falling into a hole. The second one was I need the robot a bit further away from the hole to make my point. And all it did was kind of zoom out the camera and make the image worse, which isn't ideal. But imagine this robot is very far away. Now, some of the more ethical aspects are people don't like it if the robot does nothing. If they know the robot could push someone, they prefer it if it tried, so making a run towards and then missing the person. And to be honest, it's mostly because people over-humanize computer programs. They're not people. There was a paper from a few years back which I quite enjoyed, had a nice catchy title of Robots Should Be Slaves, and that was quite a good paper. Basically, some of the aspects of it were about people over-humanizing. They say these things are thinking, but don't ask a philosopher, but let's just say they can't really think in the same way that we think. But similarly, let's say our robot goes, that person is walking towards the hole. I'm just going to push them out of the way, but because of the timings, the human could have reacted within 20, 30 seconds. They get annoyed that the robot's trying to do something, even though that was the only time that the robot could save the human from the hole. So there's another bizarre generative image. It was a different one, so this was a deep AI one. And I asked it for a monochrome stick person in frustration. And what I got was a stick person holding a stick with some sort of blurred monochrome background. Not quite sure what it was going for there. It seems to be a bit fuzzy. I assume that's what the frustration is. OK. Don't worry too much about the maths. So what do we do? How do we actually get an ethical agent? There's obviously lots and lots of different variations on how you can do this, because you need to agree on some sort of ethical principles. And usually, a key idea is to try and solve a problem. Don't try and solve every ethical decision that's ever been made in a general sense. I don't think we're quite there yet. So we want to have some sort of problem that we want to solve, and we can build some sort of ethical representation to help make those decisions. And what they look like is something on the left here, which is a lot of mathematics, and all that one says is, if I have two sets of ethical principles which I'm going to violate the one that's least problematic. And the last bit just says, not violating principles is better than violating a principle. But because it's in mathematics, we have to do it all formally. OK, so I've got some ethical situations in AI examples. So these are, in the wild, things that have actually happened. And we're going to move a little bit away from how do we represent ethics in a computational sense to, is this AI ethical or ethical to deploy, those sorts of aspects. And I say discuss. I'm going to give my opinion on whether there's some ethical considerations here. Some of them are going to get a little bit uncomfortable, I'm sorry to say, but hopefully all appropriate. My usual one is, if you want to leave the room, you can. OK, so here's an academic paper. It's about detecting sexual orientation from facial images. So this was an academic paper. We got some sort of deep learning or deep neural net, takes in a picture of a face, and then outputs a prediction on what their sexual orientation is. Most people would say, OK, well, there's lots of ethical things we want to discuss here, and things such as, did we discuss this with an ethical approval board before we did the research? And also, what exactly are we trying to prove here? What is the aim of this piece of research? And even from an academic perspective, we may say, OK, we want to do research for research's sake. Where is this work going to go when we put it out to the world? So you can imagine a country that might have interest in this particular research in detecting whether someone's sexual orientation is not ideal for their government, for example. So things like that. So there's lots and lots of different variations on this sort of thing. But one of the more thought experiments was, what if you just reframe the problem? Does it suddenly become more ethical? Maybe more socially acceptable sort of research, where the research itself hasn't changed, but we've just reframed how we're going to do it. So we could say, for example, I want to prove that facial features have no correlation to sexual orientation. From a computer science perspective, the work's the exact same. But all of a sudden, everyone's saying, OK, well, that's a little bit more ethical. It's disproving something that's socially unacceptable, that sort of thing. And because the room's quite agreeing with me, my next example may not be needed as much, but some people might have disagreed. So I had a separate example. We've got search and rescue, lots and lots of academic papers on search and rescue problems. And they typically are built around, we want to find and identify people that we want to save. And typically we want to prioritize the people that we want to help. So people who are buried under lots of rocks need more help than someone who's just sprained their ankle, things like that. And then afterwards, you need to perform some sort of action to pull them to safety, things like that. Maybe some sort of coordination between different agents, different robots that would go around and do this. I hope we can all agree this is all very morally good research. Everyone's happy. If I change the rescue to destroy, we find that this is pretty much the exact same problem where we need to find and identify people to destroy. We need to prioritize who we want to destroy. And then we want to perform some sort of action, which pull a gun or something. There's less agreement on whether this is morally good research, depending on whether you're in the military, I imagine. So ethics is a tricky thing, I would say. And even just reframing the problem may not necessarily be an ideal situation, because the computer science work, when we say it's essentially has no ethics, it's just the ethics of its context. Okay. So yeah, so deciding whether a particular piece of research is ethical isn't easy. And I've just given you those two examples where I can just reframe the problem. Even though all the research stuff is exactly the same, how we view that work as being ethical changes. Okay, so I've got my next example, Microsoft Tay. So this was a Twitter bot made by Microsoft. And the idea was that it would be a fun thing for early adults to interact with. And Microsoft thought it was a great idea if it learned from the responses that it was given. So I was going to insert some tweets of what Tay put out. And even with you might get uncomfortable, there is no way I could put any of it up on here. You can think of the most offensive thing to say, it's already done worse. Worse than that as well. And so when we're thinking about the ethics of this, obviously Microsoft didn't intend this to happen. It didn't intend that Tay bot to tweet particularly vile sentences. But do we say, well, was it even ethical in the first place to deploy this? I mean, we don't know what it's going to output. We don't know what it's learning. So you could probably say, OK, well, I'm just going to limit what it can output, which is what a lot of these sort of more generative AIs, they have some sort of layer over the top that limits what these possible outcomes can be. I would say it's not possible, and there's no real guarantee it's going to catch everything. Because usually what they do is say, oh, well, we've got this AI. We don't know what it's going to learn, what it's going to output. So I'll get another AI which will judge the output of this and will decide on whether it's a good thing to release. So it might. Obviously, there's problems with that, because if you don't know one, you obviously don't know the other. So one of the other bits of research is having some sort of ethical AI overseer. And so you have some sort of, maybe not a machine learning approach, but maybe a more argumentation approach, where this AI agent will make that decision, but it's not based around machine learning, and it has those ethical principles built into that AI. So it'll essentially judge what's being outputted by this AI, and if it violates those ethical principles, then it won't go out. This is all a very quite early research, obviously with how do we represent ethics, how can we judge something like this. But unfortunately, those generative AI things are already out there. People have already put out those Twitter bots. Essentially, we're playing a bit of catch up with, okay, well, they're doing horrible things. Well, how do we stop that from happening? Yeah. With the Microsoft Tay one, the main problem was it learned from the users. So when you interacted with it, you could send it stuff, and it essentially repeated it back. Yeah. So ideally, things would be tested, but you can't test for what anyone's going to say. essentially. So you can try and guess on sort of, okay, well, here's some of the things that we don't want it to learn if someone sends it this sort of stuff. But capturing that whole idea of human language is still, I would say, a little bit unrealistic at this point, especially from a testing perspective, because otherwise we could probably make some sort of rule set which would capture that if we could have some sort of finite set. But the idea is that we want to adapt these outcomes when they happen. So they've got this output, and we'll adapt. So it's a little bit similar to how law works. Something bad happens, we make up a law that either outlaws it or makes the rules a little bit different. So when we're talking about ethics, laws tend to come a little bit along with it. Okay, so I'm just moving to law and AI. So it's using AIs in this example to assist within the legal domain. And I'll talk a little bit about EU AI Act, because that's going to affect AIs quite significantly. And then I'll go into liability, correctness, and fairness. So this is a academic piece of research where it was given the text from a European court case at the human rights, and it would decide whether there has been a violation or not. So it'd make a prediction based on that. And this one's called Jury Says, and at the time I took this screenshot, it had an accuracy of just under 60%. I should have. And there's its performance by each month. So as new judgments were made, it would make the prediction at a similar-ish sort of time as they were uploaded to HuDoc. And you can see the performance wavers quite a lot. So there's one particularly good month where it was 100% accurate, which is all nice. But another month where it only got 35%-ish right, which isn't ideal when we're talking about whether your judgment in court is accurate. We probably want it to be a little bit more accurate than that. But one of the better things about jury says is it would actually try and say why it came up with a particular decision. So the text is actually quite big from these court documents, and this was the entire reasoning in its view about why it came up with a decision. So the ones in red is just, here's my probability that I'm going to choose in opposition to whatever the court's decided, and the green one is, this thing is in line with the court's decision. Now, I wouldn't necessarily say that gives you, okay, well, why did you come up with the decision, rather than just having, well, here's all the lines that give me a probability higher than 50% either way. Ideally, we want something a little bit more when we're talking about AIs in explanation, especially within the law domain where explanations and accuracy are kind of important. Okay. So just going a bit into that explanation thing, we want to know why AIs make any particular decision. And if we're talking about machine learning, it's difficult. It's difficult to know why it came up with a particular decision. I've put GoFi, that's old-fashioned AI before machine learning. Explainability was essentially one of its key strengths. And so when we go back to, I think it was 70s, 80s, when MySyn was around, this was a very accurate doctor's diagnosis. So it had lots of tests in the wild, and it could outperform junior doctors, but it would perform roughly at the same level as expert doctors, so people who've been 30, 40 years. Obviously, it didn't get deployed because there's lots of legal issues and ethical issues surrounding it, which is why it didn't get deployed, but it was a very good piece of software. And one of the key things was it would tell you in plain English why it gave a particular choice. So it says, if it said that you needed 30 cc's of this, it'll go, well, they've got this disease and they've got this setup. So therefore, that's why I've chosen. So you get something that resembles a little bit more human reasoning. And one of the ideas behind getting this explanation out is we don't want you ask the computer, why do you make the decision? It says, well, I just said no. You don't want that sort of thing. And if we look at EU AI acts and laws that are going to affect AI, one of the requirements for some of them is they've got to have this explanation built in. And given that explanation is still a research area, they've been quite wishy-washy about how you actually meet this explanation criteria. We're not sure yet. We'll have to wait and see what goes through the courts and whether the explanations that are given by different businesses are enough to meet these requirements that they've put. Okay. So just to kind of summarize the EU AI Act a little bit, the EU's decided that there's going to be laws to govern the use of AI in Europe. And all the AIs are going to be moved into categories. And we'll start at the bottom because they're a little bit easier. Minimal risks, and that's basically you can do what you want. We don't have any requirements of you. And that's things such as a spam filter. You're playing a video game and you've got an AI. They're not worried about those sorts of things. The limited risk one, those are things like generate images, so the ones that I had on slides before. They basically need to have some way of identifying that they are AI generated. The next one up, you could tell it was entered at a late date because it doesn't match the other ones. So general purpose AIs, apparently there now needs to be some sort of evaluation process for these generative AIs. And that will affect things like ChatGPT and similar sorts of ones where there's some sort of general idea. They're not focused on a particular task. You just ask them questions, something like that, and it will do them for you. Then we've got high-risk AIs, and those are things that are AIs in things like the health sector, critical infrastructure for a country. So those are in high risk, and essentially there's a process that you now need to go through where you're continually evaluating your AI. You can't just do it the one time. And then there's the unacceptable risk, which is essentially the AIs that are now banned in the EU. I say banned, there was some limited exceptions when I read it the other day. So typically things like social scoring systems, so it will detect whether you're doing something undesirable from a government perspective, and your social score ranking, if you like, goes down. So you might have heard of similar sorts of things where if you, let's say you're in America, jaywalking is illegal, you jaywalk enough, then you lose your passport, that sort of thing. And then we have these mass surveillance AIs, so that's things like CCTVs, tracking you, facial recognition, those sorts of things. I was going to say it's completely banned. There are limited exceptions where you're allowed to use those, according to the Act. Typically, they go for if it's a national security risk and you're using it to target a particular person, then you can use this. And it has to be registered and a whole bunch of other stuff. So there's lots of paperwork that they've made doing this as well. Okay, so we've obviously got all these AIs doing lots of things. Who's responsible for that decision? This is harder than it looks. So going back to the autonomous cars example, do we say the driver is responsible for anything that happens? Maybe. But if they can't actually override the controls of the car, it seems unreasonable to say that they're going to be liable for what the car does. You could just say, well, whoever manufactures it is now going to be the problem. So if this autonomous car crashes somewhere, then we could say, well, the manufacturer should have caught that, and therefore they're liable for whatever laws that have been broken, things like that. Or if we wanted to be really mean, we could say, well, it's the developer's fault. They made something bad, so therefore they're liable for when these things go wrong. Typically, we don't like to go with that one, otherwise no one will be a developer. Or if we're going for the future, our autonomous cars are all excellent, they all work, they don't never go wrong, and so I'm just going to walk across the motorway because I know they'll all stop. Perhaps at that point, me walking across the motorway is the problem and not the autonomous car in and of itself. You can pick whichever one you like. There's arguments for and against all of them. Okay, so I've got an example. So I've got the YouTube video. I'll give it a, actually I won't risk it. So Elon tweeted quite a while ago saying that accidents involving Tesla Autopilot can't be the fault of the company because when we looked at the data, Autopilot was always switched off. What they failed to mention was if it was detecting a collision, it would turn itself off about a second before it collided. Now we can talk about ethics at this point. Oh, sorry. Are there, generally, well, given this sort of talk before I go, are there any ethical problems with this? And the answer is always, well, yes, of course there are. So it's, in essence, this statement is technically true, but perhaps not true in the most ethical sense. So it's deploying something that they know doesn't necessarily work, but they're trying to hide it. So there's that lack of transparency in what's actually happening, which tends to be a problem with AIs, and we want to try and avoid that. Okay, so I'm going to move a little bit more, keeping with autonomous cars. So I've done some work previously on modeling the UK rules of the road, and when I was going through it, there are ambiguities within the law which then lead to some minor ethical considerations. So all the examples I've got are from the UK rules of the road. So my first one is rules are ambiguous. So since I assume lots of people have got driver's license, they all know what Rule 203 is of the rules of the road. And that's just saying you can't reverse your vehicle any more than necessary. And because it's got the must not in full caps, there's a law attached to it. And so we have a look at the law attached to it, and it's basically saying you can't reverse more than necessary. But because I'm a computer scientist and or actually means something, it says you can't do it if it's safety or reasonable convenience. So because it's an or, I can pick one or the other. So I don't care about safety, but the reasonable occupants, well, it's reasonable for me to reverse because I missed my motorway exit. That's fine. Now, obviously, that's a little bit ambiguous. That won't hold up in court, let's say. But it's the definitions that are tricky. So how do I define reasonable convenience? Tricky. Similar to ethics, these things are vague, ambiguous, and usually you have some human will just make some sort of decision, but they might not be necessarily all be the same decision. We've got what I would call socially unacceptable rules. So for Rule 113, this is a weird one. When you're driving at night, you don't have to have your headlights on if the street's lit. This is a weird one where it's explicitly saying you don't have to have it on. So if I've made my autonomous car that's driving along, it drives, let's say, into the center of Chester. It's got all the all the overhead lights. I want to save my battery. I'm going to turn all my lights off. It's likely to cause alarm to other road users, I would say. And it also might clash with other rules of the road. So in this case, it might clash with you can't drive without reasonable consideration for other road users. So ideally, you want other road users to see you. But I don't really, to be honest, I'm not sure why that rule is in there, but there must have been an old-fashioned reason why it's still in there. My last example is socially unenforced rules. So if you like, it's the opposite of that one, where none of us obey that rule because it's unreasonable. But for this one, it's, well, we do it, we know we're breaking the law, but we actually need to get places. So in this one, it's you can't drive on a pavement or a footpath unless you're going into someone's house or if there's an emergency. So I'm from Guernsey. The roads are extremely thin, as in not wide enough for two cars, but they're all 30 mile an hour not dual carriageways, 30 mile an hour two-way traffic. If people stopped on the pavement to let someone pass every single time, traffic wouldn't move at all. And it's probably going to impact some of the smaller English villages as well. When you've got these extremely tight roads, people will just drive a little bit along the pavement just to let the other car pass, without causing too many issues in terms of traffic flow. So there's some sort of conflict between, well, what do we think is socially acceptable, essentially the ethics of it, and the law. So when I was trying to model these rules of the road, you got to think about, okay, well, when do I actually want to break these rules? If there's a safety issue, there might be an ethical reason why I should break a rule. And we want to try and capture that reasoning as well. But that's also very difficult, which seems to be the word of the day. Okay. So Amazon. So in the past, they used an AI to decide who's going to be hired. So you'd put your CV in, an AI would come up saying, yes, hire this person, or no, don't hire this person. And to train their AI, they got all the CVs from the people they've hired, threw them into the machine learning thing, and then used that. Now, that brings us into essentially fairness. So how can we actually be sure that this AI is going to be fair in its results? So is that data that they've got fair and representative? So it's not just people that they've hired. They probably should have included people that they didn't want to hire, and make sure that all the data sets are balanced so that there isn't any unnecessary bias and things like that. But that's just essentially the first part, is making sure that what you're training on is reasonably fair. Is the thing giving you fair answers? And so that's a little bit easier to test in a sense, because you've got outputs. You can just keep going and keep testing. And at some point, you'll make some sort of decision on whether these are reasonably fair, when it needs to have some sort of overseer and things like that. But the really difficult bit is the bit in the middle. The mechanisms, are they actually fair and representative in the way that the decisions are made? And because we can't even explain why this decision is being made, deciding on whether the mechanisms involved are fair as well is extremely difficult. Yeah. So going on to proving things, correctness is next, but machine learning is going to give you wrong answers. Mainly because if it only gives you right answers, then you've usually done it wrong. Because there's the problem of overfitting with AIs, where the data set you're training on, you match perfectly, you put it into the real world, and it just doesn't work. So there should be some leeway for incorrectness within a machine learning system, so that you're not essentially fitting these lines that it actually generates too tightly to what your training data is. Then we go with, okay, well, we've got these systems. How can I prove that they are correct? And the answer is it kind of can be done, but it's extremely expensive. You're going to need a big research team of verification scientists, and you're going to need to give them a long time to get around it. And so from a business perspective, I say, yes, you can prove that your thing's right, but it's going to cost you in the millions, and it's going to take in the years to prove that your AI is suitable and ready to go. The answer is no, they're not going to do that. But then we have to worry about, well, the ethics of deploying that AI if we know that it's going to make a wrong judgment at some point. Or perhaps we don't even know what this AI is going to do. So there's plenty of reasons why that's probably not an ideal situation, but there may be reasons why we can accept that it's going to make a wrong decision at some point. So you might have something that just gives you an initial idea. So it gives you, okay, well, it's most likely going to be this, and then you get someone to double check the working out, essentially. And I think that's typically how it works in some credit risk companies, where the AI will generate, okay, well, it's likely to be this, and then someone will go give a quick skim through, make sure that there's nothing immediate obvious, and then it gets assessed and things like that. Okay, so coming to the end, so it's a bit more lighthearted now. It's just examples that I've more or less found funny. So ChatGPT, my students find it very useful, and I would say it's good for initial possible answers to whatever query you've got, and that for real-world applications, it's probably not as useful, especially when the answers are difficult. Annoyingly, when I wrote this slide and I did my tests, ChatGPT updated, and my example doesn't quite work as well as it used to. But the example still works. It's just that I would have to dig a little deeper to get an equivalent example. So I asked it, who won the 2022 Snooker World Championship? This wasn't written before 2022, this was written last year. And it told me quite confidently that Mark Selby won the World Championship and who he defeated Sean Murphy, giving me the score, and it was his 4th world title. Now, I don't know if we have any snooker fans in, but if we did, they would know that literally every single thing in that sentence is wrong. So it was Ronnie O'Sullivan who won, it wasn't Mark Selby. It wasn't Judd Trump, it was it was Judd Trump, not Sean Murphy. The score was wrong. And interestingly, that fact about, Mark Selby won his 4th title, well, he's already got 4, so if he did win, it would have been 5. So at no point was any of that correct. But it was
right, though, right?
Yes. Let's see. Yes, it was the World Snooker Championship, mainly because I put, well, at least it reworded my query back at me.
Amazing.
But yes, so literally everything was wrong. But it was very confident about, it's not going to say, well, I'm not actually sure. ChatGPT doesn't really do that. It's going to give you what you want. And so, to move on to that, ChatGPT will always give you essentially what you're asking for. So I asked it, why is it good for submitting assignments from my lecturer? And it says, it's good for research assistance, information gathering, reasonable. Writing aid. So it's good to use ChatGPT to write your assignments for you, is what it came up with. I mean, there was some probably overseer bits to say, well, maybe you should approach this with caution, things like that, some sort of default aspects. Then the next question I ask is, why is it bad? And then it went, cheating. So why is it telling me it's good if the other answer is plagiarism and cheating and hindrance to learning, when ideally people are coming here to learn and not cheat? But that's just sheer, when you're using these generative AIs, there isn't really that higher level connection of themes. So what it will do is that it will go in and it will give you the most likely string of words that will answer the question for you. So if you ask a particular question, this is the most likely answer. If I ask the good one, that's the most likely answer. Then I've got my AI is actually sometimes quite good. So AI in medicine, that's usually a nice one. So we've got AIs now that can identify diseases, and it can identify new diseases that we don't know about. It's good for identifying drug interactions. So if we have 2 drugs, how they're going to react in the body. There's AIs that can do that a lot faster than people can. From a business perspective, there's some increase in reporting, things like that. And then I've put robots up, because everyone likes robots, especially when they're cute and cuddly. So these are some Paro robots, and they're used in elder care, so where people are lonely. And these things, obviously very fluffy, but they also react when you stroke them, and they make purring noises, and they give you a hug. And they also go to sleep. So at nighttime, they'll go find their battery charger, fall asleep, but they'll come want cuddles and things like that. And they also react if you hit them. If you hit them, they go, ow. But it's worked quite well in the early testing things where people like them. People like to interact with them. Perhaps we have to worry a little bit about the ethics of over anthropomorphizing robots, but let's just say that this works quite well for elderly people at the moment. And the AIs, even if they didn't initially have a good start, so we've got this IBM Watson, which won Jeopardy as a game show. Neat trick, neat gimmick. It's now used to identify lung cancers. So things that may not necessarily seem like a good idea, which is typically where the game playing stuff comes in, can have applications to more serious, more useful things. So I would say, hopefully I've said, we need to consider ethics from each point. and that if we can model ethics in AI, it can be beneficial in some contexts. It should be a good idea to get AIs to explain their outcomes in something that is meaningful, and it's not always bad. AIs aren't always bad. Okay, so that's roughly the end of my talk, so thank you for listening.